For this video, I thought it might be fun to make a light fixture using a standard canning jar. After digitizing the jar, I was able to develop base geometry, as well as a variety of options for the cage. I quickly realized that the old MakerBot was too small for this project, and I would need to upgrade. Luckily, around this time, JG Maker reached out to me with their brand new IDEX printer. Before I can get started on the molds, I need to quickly assemble my new printer. Don't worry, this goes pretty quickly. The printer itself is extremely well packaged. Here you can see everything that they include to get you started. The machine requires very little setup, and their labeling system makes it extremely easy and straightforward. IDEX stands for Independent Dual Extruders. This is useful for printing two colors or even two different types of filament. After a few calibration runs, the prints were looking great. Here you can see the dual print heads taking turns at printing blue and yellow filament. Although printing in multiple colors is fun, I was most excited about being able to print with dissolvable filament. For example, carbon fiber and the dissolvable filament from Polymaker. This keeps the support material from leaving marks on the final piece, as it fully dissolves in water, which is perfect for printing carbon fiber, as it leaves the surface blemish-free. Now with a few multi-day prints ahead of me, it was time to get started on the patterns. The prints were remarkably smooth for FDM. I just lightly sanded the patterns before finishing with polyurethane. This is to provide a smooth, watertight surface for the sodium silicate sand. You can see that the larger models are not an issue, as this dome mold is over 8 inches tall. Since the cage geometry is 6-sided, I would have to make a 3-sided mold with a center plug. I could have cut these on a bandsaw using paper patterns, but lasers are cool too. The structure will locate the smart 3D printed components within the bucket and form the seams of the mold. The wooden pieces are also coated with polyurethane. This is to keep them from sticking to the sand. The idea for this mold is to use a bucket to provide the outer form. This way, I could eventually produce multiple molds and pour them separately. To remove the bottom of the bucket, I'll use a copy router bit. This will push over the formwork and provide a 3-chamber pattern for the cast sand. In the past, I've used fine masonry sand from Home Depot. For this cast, I wanted to compare it to legit F75 foundry sand from a foundry supply store. You'll notice that it behaves a little differently, but is very similar, and I didn't really notice a big difference in price or performance. The bag from Home Depot is a couple bucks cheaper. I've coated the patterns with mold release, and I'll dust it with talc powder. I originally wanted to do this project using resin-impregnated foundry sand. Due to a variety of factors, I was unable to find a good source for it in smaller quantities. Let me know in the comments if you know where I might be able to pick up a couple 100 pounds. Because sodium silicate must be exposed to CO2 in order to cure, mold walls can't be more than about 2 inches thick or it won't cure. Resin-impregnated sand relies on a chemical reaction, so it'll cure in a few hours versus days for a thick mold. This mold was left overnight until it could be flipped. Since sodium silicate sand cures with CO2, injecting it directly into the mold will help speed up the process. Earlier, I drilled some holes in the 3D pattern so I could inject some CO2 along the pattern face. Now, this can be unmolded and assembled into the final form using wood glue. The disadvantage of sodium silicate versus resin is that it is more delicate and the cure times are longer. These 4 parts are glued together to make the final mold. Generally, I don't cast aluminum in the winter. It can be a bad idea for a variety of reasons. Molds being too cold, and the feeling of being surrounded by potential steam explosions are two of them. It was approximately 3 degrees Fahrenheit during this cast, so I placed the mold on a turkey fryer to stay warm. Here I am degassing and removing the dross. The mold filled up a little bit quicker than I expected. Initially, I worried that the aluminum wouldn't fill all the cavities. Then I remembered some of the crazy ant colony castings I've seen. I was happily surprised to see a complete piece when I shook out the mold. The thin flashing was easy to snap off by hand. Before I could finish the cage, I will need to pour the base as well. This was a simple shape with a complex core that will provide threads for the jar, hole for the light, and countersinks for the fasteners. Once the core had cured, it could be placed in the mold and the flask could be closed. With the two parts complete, I just needed to cut off the sprues and runners and clean up the castings. People commented last time on how much work it was to remove the texture from a cast. Hopefully, this gives you an idea of how easy it is. That being said, I think I'll keep some of the texture on this one. The integrated threads keep the lid in place. The base of the cage is drilled and tapped for a 1/4-20 grub screw. This screw will hold the cage in position. Now I just need to finish up the electrical and install the light fixture. I'm glad this turned out as good as it did. I'm also happy with the texture on the aluminum, as I think it adds to the overall custom modern rustic ball jar light fixture vibe. Thanks for watching.